Good morning and good afternoon, ladies and gentlemen, and welcome to our unit on PC hardware and peripherals. Mr. C, what's a peripheral? Well, it's not peripheral, right? It's peripheral, okay? So we'll define that here shortly, okay? And this is going to be about identifying and defining the parts of a PC and their associated functions. So what does PC stand for?
Mr. C, is it politically correct?
No, it's not politically correct in this case, right? PC stands for personal computer, okay? Personal computer. So that's what we're going to focus on this unit, okay? Because once you understand how the personal computer operates, then you can understand how other devices operate. Now, the cool thing is that there are a lot of similarities with the modern gaming system and the PC. Okay, and this will apply to both Macs and Windows-based PCs themselves. All right, we are not going to get into tablets and smart devices, and we're not going to really dive deep into laptops. So we're going to stick with desktop PCs. In other words, the thing that if you're in Mr. C's class in Business Lab right now is right in front of you, right? That's the PC. Okay, so we're going to look at that in more depth here. Alrighty, so with that in mind, let's go ahead and take care of the next slide here. Alrighty, so what are our big ideas here? And I promise I'll define that word peripheral here shortly. Well, our big ideas are thus. One, we want to identify some of the components in a PC and explain why those what those components are used for and why they're important. Okay. I'm not going to go into the engineering side of things, right? And well, I'll tell you in just a second. We're going to build interest in a segment of business information management and improve upon our knowledge of PC hardware. All right. In other words, we're giving you a snapshot here. Those who are interested in pursuing information technology, well, you've got to understand how the basic computer works, right? Those who are wanting to get into coding and programming, isn't it good to know how some of the parts of a computer operate and function together? If you're going, yeah, then you're right. If you're going, no, then maybe you might want to rethink that, okay? Because there's a lot that you need to know in regards to how a computer works, especially when you're dealing with sound and graphic user interfaces and what have you, right? So, yeah, we'll cover some of those in detail. Not graphic user interfaces, but you'll get the idea here shortly, all right? Alrighty, so yeah, hopefully we can build an interest there. All right, now if you're not interested, well, that's fine. Okay, no big deal. All right, hopefully you can still figure out what makes a computer operate. All right, so here are our essential questions. And if you're in the class, you'll probably see these also posted at the front of the class on the blue board. All right, and I probably have those printed out on the screen. All right, so here we go. How do the parts of a computer or a personal computer work together for the user? The what? The user, right? Who is the user? Well, we can dive into that real quick. Right now, Mr. C is using his PC as a tool, right? Right now, in this very moment, right, when this video was recorded, I am using my laptop, right? I am using my camera, and I have a little extra mic right here to the right of me, okay, to record this video. I am using software to make this happen. I am using the internet. So, guess who is the user of the device? Me, right? This guy, right? Now, guess who is the user of the PC in front of you? You should all have that little inchworm pointing at yourself, going, I am the user, right? You're the user. You're the one who's using the computer to be productive, to do things, right? The computer's a tool, right? So we're going to use that to do what we need it to do, all right? Now, we're also going to look at what are the parts of a computer and why are they important. Okay, that makes sense, right? Why are they important, right? Why is it important to know the difference between a system unit and a monitor or a network interface card, right? And a sound card. Why do we got to know the difference, right? Why is it that you have a USB, but the USB goes into a port? Interesting. Is there multiple types of ports, like sound port or network port? There you go. That sounds like something that might appear on a final or a midterm somewhere, right? So there you go, okay? So let's look at the basic personal computer, okay? Because that's what we're looking at here is the personal computer. All right, so here you go. There's a picture. Yay, pictures, all right? And we see here that the picture has, well, a couple different components on here. You have this big black box right here. You have this television-looking thing here. Of course, you got the keyboard and the mouse, all right? Now, let's see what pops up next. Oh, the word desktop. Yes, this is a desktop system. Just like the one in front of you if you're in the lab, if you're at home. I don't know what you're using, so, we got to just use what's in here in the lab, right, for a reference, okay? You have the desktop computer, okay? It's not a laptop because this is not designed to be really portable. Mr. C, you could put this in a box and carry it. Again, not the purpose, right? So, yeah. It is a desktop. It's designed to sit on the desk or near the desk, etc. Right? It has a separate monitor, separate keyboard, separate mouse, so on and so forth. They're not integrated or built in with each other, right? All right. You also have a desktop computer here that just came up on a picture. This happens to be what they call the all-in-one PC. And they call it the all-in-one because the little black box right here that you see the mouse or the cursor circling is integrated into the back of the display itself, right? So that's where the computer itself is. So this is the computer, this is the system unit, and behind here, the system unit is attached behind here, okay? And sure enough, you see that word system unit and you have an arrow. Well, there might be an arrow, okay? There they are, arrows. All right, so there you go, system unit. This is the system unit itself. Over here, it's integrated to the back of the device, okay? You also have the monitor, okay? The monitor is the screen, all right? The television-looking thing. That is different than the system unit. This can still be on and this can be off. However, if this is on and this is off, it's not going to do much besides no signal and shut itself down, okay? So the monitor acts as an output device. We're going to talk about that here in just a second. Now, also pictured, you have your keyboard and your mouse. We talked about that. Here's your keyboard, here's your mouse. Just like over here, here's your keyboard, there's your mouse, okay? So with that in mind, the monitor acts as an output device because information is coming out of the computer to the monitor, which is giving us visual information about what's going on in the computer, or at least what we can see what's going on in the computer, right? Now, the keyboard and the mouse, is information coming out of the computer into those? Not really, right? That is primarily used for putting information into the computer. Mr. C, how come the lights light up? It must be an output device. No, the lights are indicators letting you know what's going on, okay? Mr. C, what about that little red flashy thing underneath the mouse? Well, that is the power, right, for the optical reader, which is using light reflection to dictate where the cursor goes, okay? So it's not output, they are input, okay? There you go. So big takeaways. Desktop units, that's what we're going to be talking about in this unit, right? You got your system unit, you got your monitor, right? And you have your monitor, which is an output device, and you have input devices, which are things like your keyboard and your mouse. And of course, they can be all integrated into one if you choose to have it that route. All right, so vocabulary. Yay for vocabulary. Here we go. All right, so vocabulary. Let's talk about some things here, all right? Let's talk about first of storage devices. Okay, a storage device keeps, houses, and maintains data, okay? I'm digging around right now for a USB flash drive, right? This is a storage device, right? It keeps, houses, and maintains data. I happen to read and write the data once it is plugged into a USB drive, right? There you go, okay? So there might be something like this built into the desktop itself, okay? And we'll talk more about that a little bit later on, okay? But basically, you store things, right? A computer has to have some way to store information or store its data or store its, well, pieces of information, okay? All right, so there you go. There's some pictures, right? Over here, you got the thumb drive, the flash drive. We just talked about it, right? It's called a flash drive. Why do they call it flash drive? Well, because it writes and reads data with electrical current or flashes of electrical current, right? You also have a hard disk drive here, which is also a storage device. We'll talk more about that a little bit later on. And of course, you have another style of flash drive here in the micro SD card. Okay, micro SD stands for micro or small SD, in other words, secure digital card. Okay, all right. So output devices are any hardware that puts out information. We just used the example of a monitor, right? But is the monitor the only output device? Sure enough, it isn't, right? Because you have speakers, right? That is taking sound, okay, from the computer and turning that into it's taking a signal out of the computer and turning it into sound, which our ears represent, or we represent with sounds in our ears, right? And then, of course, you have the printer, which is giving us printed hard copies of output, okay? So sound output, printed output, all of which are giving us information out of the computer, okay? And there's multiple other various things that could also be used as output devices, right? And then input devices, usually used to put information into the computer. In other words, user wants something done and the information stored or commanded to the computer, and it makes it happen, okay? You got your scanner, right? Your flatbed scanner takes any document or any visual two-dimensional picture, and you could scan that into data on the computer, which we will see digitally, right, through the monitor, okay? And then, of course, you also have maybe a webcam. Now, this is a portable camera. It's an older one, but it's a portable camera, and this device here is actually all three devices, right? Because it's a storage device, because it has to have some way to store your pictures digitally, right? It is an output device, because you could actually take information and it puts out the information into the computer, but you can also take information out of the computer into it, right, and see things on the screen. And of course, it is also an input device, because you could actually connect it to your computer and use it to put information into the computer itself to be sent out through the internet and so on and so forth, right? So that's actually all the above. All right, let's look at some additional vocabulary. Now, believe it or not, computers don't speak a complex language at their core, okay? Now, it gets more complicated than this, but at their core, okay, they don't speak a very complex language, okay? They speak nothing more than off and on, off and on, off, on, all right? That's all a computer understands, is ons and offs, or switches, right? They call this binary code because it's representative of two, or bi, numbers. Nary, right? Bi, like bicycle, right? Bicycles, two-wheeled, right? So binary, two-numbered, all right? And that's the smallest unit of measure, okay? And now, that gets a little complicated once you start figuring out how to make commands happen. Because all a 1 and a 0 is on and off, right? Now, how do we make things represent things like sound or color? Well, you have to start putting ones and zeros together and coding them, okay? So you might have a character of data that's represented by a combination or a special combination of ones and zeros in certain lengths. How long are those codes? Well, it depends on the computer and how old it is and the modern operating system, so on and so forth, right? But in modern computing, that could be up to, let's see, it's 64-bit, so 64 characters long, okay? That's a lot of characters, right? A lot of ones and zeros put together, okay? So it could be a letter, a symbol, a number, a color for a pixel, that sort of thing, right? So a character of data. Then you have a byte. If you have enough characters of data together, you fill up one memory storage location, which is a byte, all right? So think of it like this, right? Not like a bite out of a sandwich, right? Let's say like this right here, all right? Let's say that this, let me get to something that doesn't have notes on it. This page right here is blank page, right? Let's say that one of these lines represents 64-bit code, okay? You put a couple of pieces of 64-bit code together, you eventually end up with a paragraph of code, right? Now, that one paragraph might take up a byte, or it might take two paragraphs or a page of code to take up the byte. Again, it depends on the system in play, all right? So it's just one memory storage location. So once I fill this up, right, it's one or two memory storage locations, a byte, okay? Now, if I get 1,000 pages together, okay, I have a kilobyte. Now, that's a lot of code, right? 1,000 pages of information, or maybe 2,000, depending on how the computer is configured, right? But I want you to understand this. K for kilo, right? In science, have you heard the term or the measurement kilogram? Okay, same thing, right? A kilogram is 1,000 grams. So, thusly, we could think of 1,000 bytes as a kilobyte. Okay? Then you have a million bytes. They call that a megabyte. All right, that's a million bytes or a million pages of code, maybe 2 million, depending on how the computer is configured. Right? That's a lot of data. 1 million? Holy moly, that's a lot, right? I mean, this thickness right here might only be like 200 pages, if that, right? Yeah, think about a million, all right? Then if you get a billion, yeah, that's billion with a B, right? You get a gigabyte, not gigabyte, but gigabyte. Crazy, isn't it? All right, so to summarize, right? Everything is stored on a storage device that can either be built in or external, right? The smallest bit of information is a 1 or a 0, the smallest bit of code. All right, you put some pieces of a code together, you get character or you get some base data. Then you fill up one storage location that could be like a paragraph, right, or a page, right? You get a byte. You fill up 1,000 bytes, you get a kilobyte. Fill up 1 million bytes, you get a megabyte, and then you fill up 1 billion bytes, you get a gigabyte. And of course, again, they are all stored somewhere on the computer, right? So every computer that boots on its own needs to have some sort of way to store the information, right? Well, there you go. All right, so that brings us to our first exercise here, our first activity on PC hardware, right? You got a true or false question, another true or false question, right? And then you got to think, okay, all right, which information, which thing did we talk about? Gives us visual information, right? And then on slide B, because there are 2 slides here, right? You have a question there, and don't forget the why. The why is important. Don't just give me an answer without the why, because the why is important, right? It's part of the question. And then you got a quick thing where you're asked to kind of figure out something and tell me numerically. In other words, with numbers. In other words, some numbers and some maybe a 0 or a few zeros. All right. And that gets me to the end of this recording. And we should be able to cover that in class. If not, go ahead and catch me on the next video.